Bismillahirrahmanirrahim. Assalamualaikum. Good morning for the participants in this room. For this morning, we will discuss about the new probability models, namely Rado Institute distribution, theory and application. For this part, or the part for the part one, we discuss only about the density function. For the next time, we will try to continue with the cumulative distribution function, survivorship function, hazard function, the first moment, second moment, maximum likelihood, and an application, the Rado Institute distribution to the data, of course, and then makes the comparisons with the other models. Okay, the Rado Institute distribution model based on the change the pattern of the some models in these words, such as the Linley distribution. The Linley distribution, we have known Linley distribution is the mixture of the two gamma distribution, gamma 1 theta and a gamma 2 theta, and of course with the proportion theta divided theta plus 1 and 1 divided theta plus 1. And then the Sujata distribution is the mixture of the three gamma, gamma 1 theta, gamma 2 theta, and gamma 3 theta with the proportion or the weights theta power 2 divided theta power 2 plus theta plus 2, theta divided theta plus theta power 2 plus theta plus 2, and the 2 divided theta plus 2 plus theta plus 2 respectively. And of course, the Amarendra distribution. Amarendra distribution is the mixture of the four gamma distribution, namely gamma 1 theta, gamma 2 theta, gamma 3 theta, and the gamma 4 theta, with the proportion or weights theta power 3 divided theta power 3 plus theta power 2 plus 2 theta plus 6 and then blah blah until the 6 divide the theta plus 3 plus theta plus 2 plus 2 theta plus 6. And then the Diffia distribution is the 5 gamma mixture. Okay, gamma mixture, gamma 1 theta, gamma 2 theta, gamma 3 theta, and gamma 4 theta with the weighted, this one, theta power 4, divide the theta power 4 plus theta power 3 plus 2 theta power 2 plus 6 theta plus 24 until the 24 divide the theta power flow and blah blah until the 20 flow. And then the last is Sambu distribution. Sambu distribution is the mix of the 6 gamma. Sambu distribution of the 6 gamma, the mixture of the 6 gamma, namely gamma 1 theta, gamma 2 theta, gamma 3 theta, gamma 4 theta, gamma 5 theta, and gamma 6 theta, which weights, okay, theta power 5, divide the theta power 5 plus theta power 4 plus 2 theta power 3 plus 6 theta power 2 plus 24 theta plus 120 until the 120 divide the theta power 5 plus theta power 4 plus theta plus 2 theta power 3 plus 6 theta power 2 plus 24 theta plus 120. Okay, this is the best, this is the idea to create the Rado Institute distribution. Okay, so it's mean they change the pattern of the 5 modelings like the Linley, Sujata, Amarendra, and the Diffia and the Sambu. We try to create the new models, namely Rado Institute distribution. Okay, for the first time, we will identify for the each weighted or for the X probability. Okay, K is mean the number of mixture. So K for 2 is mean the 2 mixture. gamma. Okay, it's mean the Linde distribution. With the weighted, this is weighted. This is for P1, is the for P2, or the weighted 1, it is weighted 2. Okay, and then for the K equal to 3, it's mean the mixture of the 3 gamma distribution. Okay, for the K for the 3. With the weighted, this one. This is weighted 1, this is weighted 2, and the weighted 3. And if for K equal to 4, it's mean the Amarendra. It's a mixture for gamma distribution with, this is for the weighted 1, this is for the weighted 2, and the weighted 3, and the weighted 4. Okay? And then for the K equal to 5, it's mean the diffia, or the mixture of 5 gamma distribution. With this weighted 1, the first weighted, second weighted, third weighted, fourth weighted, the fifth weighted. Okay, you must remember the summation for the each weighted, okay, it must be equal to 1. For example, for the Linde distribution or the 2 mixture gamma, if we try to make the summation P1 plus P2, of course, theta divide theta plus 1 plus 1 divide theta plus 1, of course, equal to 1. And for the Sujata, okay, if we try to make the summation for the P1 and the P2 and the P3 equal to 1. So it means for the summation of the each weighted, okay, for the specific model, for the specific, the number of K, number of the mixture distribution equal, you must make sure the summation of the weighted equal to 1. Okay. From this table 1, we can make the conclusion, okay? The Pi is mean the weighted I equal to theta power K minus I divide the summation starting I equal to 1 until K, the function gamma I, and multiplied by theta power K minus I. You must remember the gamma I, for the I, the integers, of course, we can find with the formula I minus 1 factorial. Okay, and then summation Pi must equal to 1. Okay, and then when we are trying to using the concept of the mixture, this is the concept of the mixture. The concept of the mixture is mean the weighted multiplied by the density function, the summation, okay, the summation I equal to 1 until the K for the weighted multiplied by density function. Okay, based from this information, we can create the new models. We call that the Rado Institute distribution, like in this equal to 4, and then equal in the equation 4. Okay, in the equation 4, fx equal to theta power k divide the summation starting I equal to 1 until k, function gamma function I power multiplied by theta power k minus I multiplied by summation I starting to 0 until the k minus 1 x power I exponent min theta x. For x that equal to 0, theta equal to 0, and I for the integer starting 1, 2 until k. You must be remember, k is mean it's a mixture of the number of mixture gamma density function. When we are try to using k equal to, it's mean the Linde. If we try to using k equal to 3, it's mean the Sujata. If we try to using k equal to 5, is Dipia distribution. And when we try to change k by 6 equal to, it mean the Sambu distribution. And then for the Rado Institute distribution, like in the equation 4, we can use the number the number k. You can use the 10 mixture gamma. You can use the 20 mixture. It's up to you. There are no limited when we are using this formula. Okay, this is the good of the Rado Institute distribution. Okay, for example, if we try to make the k equal 2 and then using the formula like in the equation 4, we can find the density function of the linear distribution. And if we try to k equal to 3, we can find this density function is the Sujata. And if we want to try k equal to 4, this is the density function of Amarendra. And if we will try to change the k equal to 5, we can find the density function Devia distribution. So, in the Rado Institute distribution, we don't care about the weighted. We don't need the weighted or the proportion type. We don't need that. In the Rado distribution, we direct using the density function like in the equation 4. We are not important to the thinking what is the weighted or the proportion. This is very different with the other models like the Linley, Sujata, Amarendra, Devia, and Sambu. For this model, we must focus to the proportion. Okay, like we are discussed in the table 1. This is for the proportion or weighted. And then in the Rado Institute distribution, we don't need the information of the proportion. Okay. To make sure the equation 4 or the density function of the Rado Institute distribution is a good density function, of course, we must try to show the integral or the integrated of this density function starting from 0 until the infinity must equal to 1. Okay, from this equation, you can see I give this one, I block this one. You can see we success to prove the integral of the density function is equal to 1. It is very easy to prove the equation 4 or the density function of the Rado Institute distribution is the correct function, because we can show the integral from the 0 until the infinity is equal to 1. Okay, and then for this reason, we can conclude that the equation 4 or the density function for the Rado Institute distribution is the correct density function. Okay, for this parts, for this times, we will enough discuss until this how to prove this equation 4 or the Rado Institute distribution density function is a correct density function. Okay, we can try to make we can try to give the we can highlight our discussion today. Rado Institute distribution is the correct density function. This is the best from the change of the sums model like the Linley, Sujata, Amarendra, Devia, and the Sambu distribution. From this distribution, we try to make analysis and try to create the new models. We call that Rado Institute distribution function. In the Rado Institute distribution function, we don't need the information about what is the weighted of or the proportion for the each density function. So I think this is good discussion. This good discussion for these times. We will continue for the another time to talk about the what is the cumulative distribution function for the Rado Institute distribution. Okay, see you again, Rado Institute and Rado Yendra. Assalamualaikum warahmatullahi wabarakatuh.